Hello everyone, welcome you all back. In this video we are going to solve some problems on heat exchanger with LMTD method. Okay, so I think this is the third problem in LMTD method. So I am giving directly third problem. In the last video we have seen two problems. This is the third problem. In this problem, in a parallel flow heat exchanger, right? So just write straight away, given it is a parallel flow heat exchanger. Okay, hot water is cooled from 80 degrees Celsius to 40 degrees Celsius. So just write hot fluid. The inlet temperature of the hot fluid is T1 equal to 80 degrees Celsius and T2 equal to exit temperature is 40 degree Celsius by cold water entering at 20 degrees Celsius. So here write cold fluid. The cold fluid entering temperature is 20 degrees Celsius. Okay. The mass flow rate of the hot water is 0.2 kilogram per second. So m dot h equal to 0.2 kg per seconds. The mass flow rate of the cold water is m dot c equal to 0.5 kilogram per seconds. The individual heat transfer coefficient on both sides are 600 watt per meter squared Kelvin. Here in the problem, while you are going to find out the Q value, you have to find out the UA del Tm. So here U value is required. Here the overall heat transfer value, the U value is not given directly. Instead of that, they are giving individual heat transfer coefficient, that is Hi on both sides in the sense Hi heat transfer coefficient inside and the heat transfer coefficient outside. So here just write down heat transfer coefficient inside is equal to heat transfer coefficient at outside is equal to 600 watt per meter squared Kelvin. Right? These are all the given data given in the problem. Right? So to find the area of the heat exchanger. So to find area, okay, in the first step you have to find out there are only three temperatures given in the problem, T1, T2, small t1. These three temperatures given in the problem. So you have to find the fourth temperature, that is T2 value you have to find out. This T2 value has to be find out. We know that QH equal to, that is heat lost by the hot fluid equal to heat gained by the cold fluid. QH equal to QC. We know the formula MH CPH of T1 minus T2, which is equal to MC CPC of small t2 minus t1. So from this equation, just substitute MH is 0.2, CPH is 4186 because it is given as water. No, for water the default value of specific heat is 4186 into T1 minus T2, that is 80 minus 40, which is equal to m dot c is 0.5 into again 4186 into T2 value is not given in the problem. T1 is 20 degrees Celsius. By solving this equation, you can find out the T2 value. Okay, T2 equal to 36 degrees Celsius. This is the first step in the problem. So in the second step, you have to find out the heat transfer value, because at finally what we are going to find out, Q equal to UA del T LM. From this formula, you are going to find out the area. So in this problem, del T LM has to be find out, U value has to be found out, Q value has to be find out. Okay, so now you know that Q equal to MC CPC T2 minus T1, or in the hot side MH CPH T1 minus T2. Substitute all the values here, 0.5 into 4186 into T2 value is 36 and the T1 is 20 degrees Celsius. You will get the answer as 33.4 watts. This is the value of Q. Now in the second step, you have to find out the U value. To find out the U value, that is overall heat transfer coefficient, in the problem the individual heat transfer coefficients are given. So to find out the overall heat transfer coefficient, from the data book you have to write this formula. Okay, while writing this formula in this problem, only H naught, HI values are given. There is no value as RF naught, RFI, R naught, RI. All these values are not given in the problem. So these values has to be omitted from this equation. So RF naught is not given. Similarly, R naught, RI, this value is not given. RFI value is not given. So the remaining values are 1 by U equal to 1 divided by H naught plus R naught divided by Ri Hi. Here also the R naught and Ri values are not given. So just omit these values. So here 1 by. So the final equation will be 1 by H naught plus 1 by Hi. Okay, this value you have to use to find out the overall heat transfer coefficient value. So you know that 1 by U equal to 1 by H naught plus 1 divided by Hi. Here it is 1 divided by H naught, 1 divided by Hi. Okay, substitute these values. So you know that from here divided by, so I am taking the LCM, H naught into Hi. So Hi plus H naught is equal to 1 by U. So U becomes H naught into Hi divided by Hi plus H naught. Just Hi and H naught values are 600 into 600 divided by 600 plus 600. The value is 300 watt per meter square Kelvin. Okay. So the remaining value you have to find out is del T LM. For this you have to take the formula. Okay. In the problem itself they given that the heat exchanger type is parallel flow heat exchanger. So from data book write the page number, I think 152, for parallel flow heat exchanger del T LM equal to T1 minus T1 minus T2 minus small t2 divided by ln T1 minus T1 divided by T2 minus T2. Substitute all the values here, like 80 minus 20 minus 40 minus 36 divided by ln 80 minus 20 is 60 divided by 40 minus 20 36 is 4. Okay, this value you have to find out. Del T LM will be 20.67 degree Celsius, and finally you have to find the area value. To find the area value, you know the formula Q equal to UA del T LM. Okay. Okay, Q value is nothing but 33.4 kilowatts. Okay, you have to substitute it here in watts. So 33,400 watts, which is equal to U is 300 into area value you have to find out into del T LM is 20.67. So to find the area value, it will be 5.40 meter square. Okay, that will be the final answer. Now go to the fourth problem of our lecture series. So write the given data in a parallel flow heat exchanger. So parallel flow heat exchanger, hot fluid enters at 400 degrees Celsius. So T1 equal to 400 degrees Celsius and leaves at 250 degrees Celsius. T2 equal to 250 degree Celsius, and the cold fluid enters at 50 degrees Celsius. So T1 equal to 50 degrees Celsius and leaves at 110 degrees Celsius. So T2 equal to 110 degree Celsius. The inside and outside heat transfer coefficients are 120 and 190. So Hi equal to 120, H naught equal to 190 watt per meter square Kelvin, watt per meter square Kelvin respectively. The inside and outside diameter of the tube are 0.6 meter and 0.08 meter. So inside diameter is D I equal to 0.06. So Ri equal to 0.03 meters. Okay. So outside diameter D naught equal to 0.08 meter and R naught equal to 0.04 meter respectively. If the heat transferred per hour is 1.6 kilojoule, find the length of the tube. So in the problem itself they are giving the value of Q. So Q equal to 1.6 into 10 to the power 5 kilojoule per hour. Okay. So to find length of the tube, so you have to find the length. Here Q has to be converted into the watts. So watts is equal to, you know that watts is equal to joule per seconds. So 1.6 into 10 to the power 8, that is 1.6 into 10 to the power 5 into 10 to the power 3. So 10 to the power 8 divided by 3600 joule per seconds, which is equal to 4444.4 joule per seconds, which is equal to 44.44 kilowatt. Okay. So with all these data we are going to solve the problem, right? So to find the length you have to use the formula Q equal to UA del T LM. So here in this formula the Q value is available. So U value has to be find out, del T value has to be find out. If you know the value of area, then you can find out the area of the length. So first thing you have to find out del T LM. So in the problem itself they gave it is the parallel flow heat exchanger. So from data book page number 152 for parallel flow heat exchanger, del T LM equal to T1 minus small t1 minus T2 minus small t2 divided by ln of T1 minus small t1 divided by T2 minus small t2. So substitute all the values here, you will get the answer as 229.25 degree Celsius. This is the value of del T LM. Now you have to find out the value of U. So from the data book, likewise in the last problem you have to take the formula 1 by U equal to 1 by H naught plus R naught divided by K ln R naught divided by Ri plus R naught divided by Ri into Hi. In the data book the values of Rf naught, Rfi values are given. Here in the problem these two values are not given. So I just omit all those two terms in this equation. Now I have to find out from this equation the heat transfer coefficient. Now in the problem the K value is not also given, so this term also has to be omitted. So final answer will be 1 by H naught plus R naught divided by Ri into 1 by Hi. So substitute in this equation all the values. R naught is 0.04, Ri is 0.03. Substitute the values, you will get U value as 61.35 watt per meter Kelvin. Now we know that Q equal to UA del T LM. Okay. Now Q value is 44 kilowatt, no, 44,444 watts, which is equal to 61.35 into area into del T LM is 229.25. So just find out the area value. So there will be a area value and this value equal to pi into D naught into length of the pipe. So D naught value you know from this equation, you can find out the length of the tube as 12.57 meter. Okay, this is the final answer, and in the next video we will solve some more problems on heat exchangers with LMTD method. Okay, thank you all.